Okay, so welcome back, and now what we're going to do is we're going to talk about magnitude and direction of a vector. Okay, so we've talked about magnitude and direction before. We've talked about how to calculate magnitude, not of a vector though, but we did talk about magnitude with regard to a point in polar notation. And so we're going to use the same definition of magnitude that we used then. So if we're talking about a vector, again, we have a vector here positioned in standard position, tail at the origin, head at the terminating point. So initial point, the origin, terminating point is in this case A comma B. And so we denote it with this way with the triangle braces with A comma B in the middle. Now, we're going to use the magnitude of V, or magnitude of the vector. So again, we could represent vector V, right? Lowercase boldface V. And the magnitude of the vector is given by this, just like we've seen before. The magnitude of the vector is basically using the absolute value. And again, this is going to be equal to the square root of A squared plus B squared. Okay? So it's going to be the square root, the positive square root of A squared plus B squared. That is how you calculate magnitude. Okay? So again, magnitude is the distance the point is away from zero. It's the length of the vector. Okay? And that's how you calculate magnitude. Now, the other thing we need is the angle, right? And so the angle theta is going to be the angle that it makes with a horizontal line that goes through the terminating point. So again, in standard position, it's just going to be the angle that the vector makes with the positive x-axis, okay? Or with the x-axis in general, okay? So now, how do we get the theta? Well, that's going to come back to the right triangle, right? So we have our x value, which in this case is going to be A, right? And then the distance going up is going to be B. And so what we're going to use is tangent of theta is equal to what? B divided by A. So which means that to find theta, we're going to have to use inverse tangent. So theta is going to be the inverse tangent of the quantity or the ratio of B to A. Okay? And so that's what we're going to use to find the magnitude and the direction of the vector. Okay? And so that's what we're going to do. Now, two vectors v and u are considered equal. Okay, so here's another thing before I let you go. So if I have two vectors, let's say I have another vector that is here, right? So any two vectors, let's call this CD, right? So any two vectors are equal if they have the same magnitude and the same angle. Meaning that, again, if I was to draw a horizontal line through the terminating point, then this angle and this angle are the same, and the magnitude of both vectors are the same. If that is true, then they are equal. Okay? If both vectors have the same position vector, obviously then they are also equal, right? So another way of looking at it is if I'm able to slide this vector to here and I get the same vector. So basically if this slides right on top and I get the same vector that I started with, you know, so if I take these 2 points and I translate it into the position vector and I get the same point, then obviously they're going to be the same, right? Okay, that's it. Let's do some examples. Take care.